So question 2.3 from June 2015. It says that studies have shown that when the blood alcohol content exceeds 0.1 milligrams per 100 mils, a person displays a slowing of motor coordination. Correct? So you can't do things in the correct order that you're supposed to have, right? And it says that as well as poor judgment in hearing. Okay. An investigation was done to determine the influence of blood alcohol content on reaction time. So if you look at that, what would that statement be? To determine the influence of blood alcohol content on reaction time. We're trying to like analyze the question before you even look at it, right? That's the aim. Good. Okay, so the aim is to determine the influence of blood alcohol content on reaction time. That means that the aim generally will have both variables in that. So what is the independent variable? Right, so the two variables will be in that aim, which is to determine the influence of blood alcohol content on reaction time. Which of those would be the independent variable? Good. Abra says the blood alcohol content is the independent, and then obviously the reaction time is the dependent. So the reaction time depends on the blood alcohol content. Right, so the reaction time was tested by measuring the braking response of a motorcyclist, and the results are shown in the table below. And we've said that generally in the table with two columns, about 90% of the time, the first column will be the independent variable. So again, we can see that the blood alcohol content is given there, and then the braking response time. And then if you just look at the data, we can see that if you look as you go down here in your first column, we're finding that the blood alcohol content is increasing, and we find that the brake response time is also increasing. Okay. Madam Lehe, there's someone asking about, they can't hear, can you just type for them that what they should do? Click on the audio on button, please. Right, so we'll continue. We said that we can see that the brake response time increases as alcohol consumption increases. Okay, so if we look at the first question, it says calculate how much longer in seconds the braking response time of the motorcyclist was when there was 0.25 milligrams of alcohol as compared to when there was no alcohol in the blood. Right, so we look here. Who can give us that answer? It's a calculation, so you need to do some calculation. Good. Iram says 0.610 minus 0.572, and then the answer is 0.038 seconds, right? It's good that you have to have the units as well, and you'd show your calculation also, right? So here's the memo. Can you see the memo? Right, I think you can see the memo, hopefully. It's showing you that, good, we've got 0.610 minus 0.572, which was for no alcohol consumption, and then we get the answer of 0.038. Right, so we go back to the questions. The second question says, describe the general relationship between blood alcohol and braking response time. Right, so the general relationship, I think we've given that when we were analyzing the question. So what's the relationship that's shown between the two variables? Right, as the blood alcohol content increases, the braking response time also increases. Perfect, right? So that's the correct answer there. That you must be careful when you're talking about speed, right? Because if they ask you about speed, the speed of response would decrease. Remember, the longer something takes, the speed is slower. Okay, so just be careful if sometimes they're talking about the speed of responding, because then when the numbers get bigger for time, it means that the speed was actually slower. Good. Right, so we go back to the questions there. it says then explain why poor judgment of a motorcyclist can lead to an accident. Why would it be that when a person has poor judgment, it can lead to an accident on the roads? Right. So what would it be that they have to judge basically, right? What would a driver need to use their judgment for? And if they don't use that judgment correctly, it would lead to an accident.
If the motorist cannot calculate how far another vehicle is and which direction it's going in, it takes longer to brake and sometimes not braking at all, which increases chances of accident, as well as lack of balance may lead to the motorist going off the road or on the wrong side of the road.
Okay, good, right? That first part is what we're looking for, right? Where it says that the motorist cannot judge the distance of an obstacle, right? So maybe another car or a person who's crossing the road or something like that. And as a result, they won't be able to stop in time and they won't be able to avoid an accident. The second option is that maybe they won't be able to judge the boundaries of the lane. So we've got those lines on the road to say that this is the left lane of traffic for going in one direction and the other lane is people coming in the opposite direction of traffic. So if you lack judgment, you might not realize which lane you're in, and this can also lead to an accident, right? So when we go back here, the second part, the part of that answer was saying that when a person loses balance, I wouldn't include that. Remember, they're not giving you that in the information given, right? You lose coordination, judgment, and hearing. But even if you spoke about coordination or hearing, the question was very specific to say that why does poor judgment, right? So judgment is something that happens. I don't want to give the answer because that's going to be which part of the brain where it happens. It's something that happens voluntarily, right? So that would be different from balance, and I wouldn't include balance in this answer. Okay, so identify the part of the brain affected by alcohol that leads to the following. Which part of the brain is affected by alcohol which leads to hearing being affected? So we just need the name. Good. Cerebrum. It's good, right? So we know that hearing from the organ of Corti, we know that it will go through the auditory canal, the auditory nerve rather, until it goes to the cerebrum. Loss of judgment, which part of the brain would be affected for that one? Again, cerebrum, right? Good. And motor coordination being affected. Right, coordination is how you get things working good, Lindiwe. It's the cerebellum, right? Many of you all heard that answer, good, right? So we know that for coordination of voluntary actions, it comes from the cerebellum. So you can see this question is asking something that's straightforward, but in a different way, right? We taught you the structures and the functions of the different parts of the brain. Remember, we asked you to draw the diagram. We said label and give the function. So you learn it like that. But here they're saying that now a person loses their judgment and which part is affected. So if you know that judgment, reasoning, memory, all of that is controlled, higher thought processes are controlled by the cerebrum, then you'll know that the cerebrum is damaged there. Okay, and then motor coordination being affected, coordination of voluntary actions, we know that's controlled by the cerebellum. Okay, 2.3.5. Explain the purpose of measuring the braking response of the motorcyclist when blood alcohol content was 0 milligrams per 100 ml. So we wanted to know how alcohol affects it. Now, taking this measurement here would mean that taking a measurement when there's no alcohol. So if we want to know how alcohol affects, why would we even take a measurement when the alcohol is 0? That's what the question is saying. Okay, so Ram says it serves as a control. That's good, right? But now the question is saying explain. So remember, explain question, and it's for 2 marks. So you need to now give a statement and a reason. So you need to elaborate on that. It's a control. How does it serve as a control, or why does it serve as a control? Right? Anyone can add on to that. Okay, so it shows the normal response of a motorcyclist, right? Some people would call that the baseline. For validity of the investigation, it's true that it adds to validity of the investigation, but that's what I'd say, it's vague or something generic that you can use for any answer, and they won't accept that in the memo, right? So specific to this here, why would you want to know the zero, right? So the first part you'll got of the answer to say that you'll want to know the response time when there's no alcohol, so that serves as a control or as a baseline amount. And then why would you want that measurement? Why would you need that measurement? Good. The results after alcohol can be compared with this, right? So that's, I think, what we're looking for there, right? So the previous answer, cerebrum, cerebrum, cerebellum, then it acts as a control or baseline assessment, and so that the results can be attributed to alcohol content in the blood and not any other factor, right? Remember, if we don't have this value, how do we know that that slower reaction was caused by anything else? Maybe that person is just slow at reacting, and now we measured their response after drinking alcohol, and you say, no, this is a slow response. But now if you measure that same person without having alcohol, then we're going to know that a control, the function of the control is to make sure that you have a setup similar to the experiment. All variables are the same or controlled except for the independent variable. So the only difference would have been that the independent variable, which is the amount of alcohol, would have been different. So if there's a change in the response time, we know it's definitely because of the alcohol consumption or the alcohol content of the blood. Okay. We go to the next question. This is from June 2016. They're saying that the diagrams below represent part of the central nervous system of human. Right. First, when you get a question like this, first thing you do is to label all of the different parts. What is part A? And so normally on your question paper, you'd record or write down the labels of the different parts, right? So Abras is the motor neuron, that's correct. And how do we know it's the motor neuron? You can see one, the arrow is going away from the spinal cord, so away from the central nervous system would show you that that's a motor neuron. And secondly, you can see that the cell body is here within the central nervous system right at the starting, right? So that's characteristics of a characteristic of a motor neuron. Iram said a motor nerve. Now there's a difference between a nerve and a neuron. It's quite similar, but actually a bundle of neurons makes up a nerve, right? So Halalelo, you raise your hand. Do you have a question to ask? There's also right, feel free to ask what you want to. There is this function on if you click by participants or by chat, I think then you've got this option of raising your hand, right? So you can, to get my attention, and then if you want to speak, then we can give you that opportunity to speak, or if you've got a question that maybe you want to ask in that time, right? So we're saying a nerve is made up of a bundle of different neurons. So a nerve would be many neurons together make up a nerve. Okay, so we're saying then part B would be what? Karen, like the positioning of this label. If you look at the label line, it doesn't touch this line. If it's touching this line, then I'd say it's a sensory neuron, like what Muaz is indicating there, because one, the direction is given to the central nervous system. Secondly, we can find the cell body somewhere in the middle. Thirdly, it's entering from the top. So that's also in the dorsal root of the spinal cord, which is also an indication normally of a sensory neuron. But I don't like this label, right? It should be touching there exactly. Part C, right? Gray matter, good Muaz. That's the gray matter of the spinal cord. Then part D, cerebrum, correct. Part E, so part E was the biggest part of the brain, which is the cerebrum. It's got many folds there also. Part E, good Katlejo, is the cerebellum. Very good. And then part F is the medulla oblongata, good Muaz, right? So that's the starting point of the spinal cord, just under this bump. We don't need to know. It's called the pons varoli. We don't need to know the name of that. But just underneath that, we've got the medulla oblongata. And then this part after this, what would be that continuation after the medulla oblongata be called? It's not labeled here, but just to see your knowledge. Good, the spinal cord, good Katlejo, right? So we've labeled the different parts that would make it much more easier now for us to answer these things, right? So identify parts C and D. We've already done that. Okay. Give the letter and name of the part in diagram 2 that receives impulses from the following. Right. So now if you look here, there's a lot of emphasis in this question. Firstly, letter and name. Right. You can see both of them are written in capitals to emphasize it. The examiner is really emphasizing this to you so that if you give only one of them, you're going to lose marks, right? And then you can see diagram 2 is also in bold to emphasize that only use diagram 2 for this, right? So letter and name of the part in diagram 2 that receives impulses from the rods and cones. Your answer? D, cerebrum, correct, right? So we know receptors from all sense organs come to the cerebrum. We said cerebrum receives and interprets sensations. Then receptors in the heart muscles, right? So E, cerebellum. No, Kasia, I don't agree with that one, right? F, medulla oblongata is correct. Remember, cerebellum is for maintaining your posture and your balance and for coordination of movements, right? But your heart rate is controlled by F, the medulla oblongata, which is correct. Okay, 1.5.3. Okay, so let's just look at the memo. You can see that we've got the same answers as we've been giving so far. Right, you said gray matter or spinal cord, they accepted there. Cerebrum, and then here D, one mark for the letter D and 1 mark for the name cerebrum, and then 1 mark for the letter F and 1 mark for the word medulla oblongata. If you just say medulla alone, it's incorrect, right? It has to be the entire thing, medulla oblongata. Okay, name the process taking place in diagram 1 which minimizes injury to the body. That's 1.5.3. Right, so we've got two answers. There's reflex arc and reflex action. But they both are similar and related to each other. Now, which one would be correct and which one and why? Who can tell us now? I want to know why. Which one is the correct? If you're saying reflex arc, why is it reflex arc and not reflex action? If you're saying reflex action, why is it reflex action and not reflex arc? That shows good. Okay, Iram is correct, right? The arc is the path taken or the route through which this impulse moves. Okay, so the pathway for a quick automatic response to a stimulus is what we call a reflex arc. That's the pathway, the way it moves from a stimulus going to a receptor and then the sensory neuron, synapse, interneuron, etc. Right? Whereas here we're talking of to minimize injury, it's by the action of removing your hand from a hot object or your hand from a sharp object, something like that. That is what's going to protect your body. So the best answer here would be the reflex action, right? You find reflex arc would be a common incorrect answer there also. Okay, we move to the next one. Right, if we look here, it says, give the letter and name of the neuron that transports impulses from the central nervous system to the effectors. So you have to give a letter as well as the name. Right? A, the motor neuron, Mars is correct. Okay, and that brings us to the end of the small set of questions which is dealing with the nervous system. Next activity will have more on the nervous system again.